In this video, we'll demonstrate how we import the step model of a single shaft. Before that, I'll just briefly talk about the material database. This one has a material database. You can put your materials here. You can, with this interface, you can add materials, you can delete, you can edit. Those materials will be available when you are creating the model. So this is a single shaft, importing a single shaft onto the main canvas. And this is the template and number of parts, unit, drive end, and then geometry, OD left, ID left, and all those. So you import this data and the model will be created on the canvas. This is a live model, meaning that you can drag a line, vertical line, horizontal lines and points, etc. The left hand side is a system data form with tabs. This is very similar to the rotor modeler. All the material you have chosen here, overall data, envelope length, diameter, weight, polar moment of inertia, center of mass. This is the step table. This is actually defining the geometry. OD left, ID left, OD right, ID right. You can have conical, you can have hollow, the length, and there's a reciprocal highlighting. Okay, if you select some line there, step there, the corresponding step will be highlighted on the left hand side on the step table. So the user is now changing the diameter on the canvas, okay, by typing or dragging, and then corresponding number will be changed on the left hand side table. So and the model is then exported to dialog. So it just takes 2 minutes, Next we'll show you, you start from scratch. You don't have a complete shaft, you have just a single step shaft, and you are going to create a stepped shaft from that. So we'll be importing a single one step shaft, and same, the same thing, the step table has only one step. And from this one step, the user is now creating 9 steps. He has selected a material, this is shaft. So he select the line and add 8 points. You need 8 points to create 9 steps. So those points are created. So these are all subordinate key points when you create it first. Because that means that if you drag the line, all the points will go up and down together. So you have to uncheck that subordinate, that checkbox to make it primary key points, so that each segment can be independently moved up and down. So he is making all those subordinate key points to primary key points or main key points. Okay, so this is the step table. You have 9 steps. There is a reciprocal highlighting. If you highlight a row, the corresponding step will be highlighted on the right hand side. So he is picking the first step, and he is going to change. This particular user is going to change all the diameters of the step. Okay, so there are 9 steps, and he is going to change the diameters of the steps, either on the canvas right hand side or typing on the table, whatever is convenient for you. Both are available. They are reciprocal. If you change it here, it will show up there. So he is creating all those steps. The diameters is first setting. Eighth step. Then the last one, the 9th step. Okay, so all the steps are now done. Now he is going to create hollow at the 2 ends. And when you create hollow, then the step number will increase. He is typing it on the left hand side because it's easy, or you can go there and drag the vertical line. Drag one of the vertical lines corresponding to that step. Yes, ID left. ID right will be same as ID left. Now he has increased that length. So there will be 2 steps there, and the number of steps has increased. So he is going to do it on the right hand side also. First create the hollow and set the diameter, either on the canvas or on the table, left hand side table. Now you set the thing. And again, this is reciprocal highlighting. You can see that whatever you are choosing. Yes. Now, yeah. The whole time taken is 10 minutes, and then the model is exported to dialogs. Corresponding ROT file is. Now he is showing in assembly. So there, for each part there is a different sheet on the. So he's importing that file, assembly file. and the model will be created on the main canvas. Now again, as I said, this model is live. Now you have multiple parts, multiple materials here. They have been chosen. Overall data has the envelope data, and then at the bottom we have the different single part data. There's a drop down, and each data, envelope length and diameter, weight, IP, polar moment of inertia, and the center of mass from its left hand side. This is the step table. For each part there is a step table, and you can navigate from one part to another by using next and previous. The first part is the primary. Is the bolt left hand side. Next one is the thrust collar. Then is the bolt right hand side, and then you have the impeller. Okay, so there are 5 parts here. Each of the parts can be modified. So he is going to show, he's picking up the shaft and he's changing the middle diameter here by dragging, or you can type on top of that line, or you can type it directly on the left hand side. So he's bringing it back actually, just to show you that any diameters can be changed, any vertical line position can be changed. So he's going to add points. So first, before you add any items, you have to add a point, and then you have items here. Add point in the middle, and you can move the point. Add a bearing. Now bearing is by default is connected to the rigid ground, but if you remove that J0, then a flexible support is automatically created, and that will be numbered also automatically. So by removing that 0, this flexible support is created. Corresponding entry will be there on the support tab. He has added a disc. He is going to add a station in the middle, just a simple station, so that the element will start. Add station. Very good. And then model is exported to Dyros. It takes 5 minutes from that Excel table modification.